we have to talk about harmonic perturbation. Harmonic perturbation is a special case of time-dependent perturbation. The technological advancements like masers, lasers, NMR are originated from harmonic perturbation. A maser is micro amplification by stimulated emission of radiation. If you consider the interaction of radiation with an atom, the oscillating electric and magnetic fields associated with the light can induce a transition between stationary states in atoms. To realize the term stationary states, consider the states M and L. The mth state is having energy M, Lth state is having EL. Suppose an atom is in the Lth state, after absorbing energy that can be promoted to the mth state. However, the values of EM and EL are fixed. There is no change in their energy, but transformation from one state to another state is possible. Transformation of this type is called stationary state transformation or stationary state transition. Here oscillating electric and magnetic fields mean the fields which are varying periodically with time. Let us consider a situation where the perturbation is an explicit function of time except for being turned on at time t equal to 0 and turned off at a time t equal to t0. This is on time, this is off time. The explicit function of time means if you know the trend of the system at a particular instant, we can design the trend about the future. The future of the system is also known. Then only we can call that system in explicit function of time. If the value of h1 is this much, h1 of ml is equal to psi m0 star 2a0 sin omega t omega l0 d tau. This is modified as 2h0 1 of ml sin omega t, where h10 ml is equal to psi m0 star a0 psi l0 d tau. This is the value of am1 of t. We arrived at this relation from our time dependent perturbation theory, the amplitude value. Instead of h1 ml, we have to substitute this value. Then take this 2h0 ml of 1 outside. Then we can get the equation of this form. Instead of sin omega t, we can substitute e power I omega t minus e power minus I omega t by 2i. Then 2i get cancelled. We can get minus h0 1 of ml divided by h cross. Then multiply e power I omega t into e power I omega ml into t minus this term e power minus I omega t into e power I omega ml into t, entire is multiplied by dt. Now combine these two terms using the logic of a power m into a power n is equal to a power m plus n. Say take this I outside, omega ml plus omega into t minus of e power I into omega ml plus minus omega into t. Entire is multiplied by dt. Here a negative sign is present. To change this into positive, rearrange the terms. This term is written as the first term. This term is shifted to a second position with a negative sign. So e power I into omega ml minus omega into t minus of e power I into omega ml plus omega into t. Then h0 1 ml by h cross. Then integrate this first term. E power I omega ml minus omega into t whole divided by I into omega ml minus omega. That is the integral itself. Minus of integrate this term. E power I into omega ml plus omega plus into t divided by I into omega ml plus omega. Now we have to apply the limits. If you apply the upper limit, this t is replaced by t0. If you apply the lower limit, e power I into omega ml minus omega into 0, e power 0 1. So upper limit minus lower limit is extending this term into e power I into omega ml minus omega into t0 minus 1 divided by omega ml minus omega. Just we have taken out this I outside. Similarly, the second term is changed as e power I into omega ml plus omega t0 minus 1 divided by omega ml plus omega. Now we have to give interpretation for this term 4. The value of a m1 of t, that is the amplitude, depends upon t0, not t. t0 is our perturbation time. The transient probability is valid, that is transient to the mth state is valid. The transient to the mth state is given by the formula a m1 of t absolute square and is obtained by multiplying a m1 of t into a m1 star of t. To calculate the transient probability, we should assume the denominator of the first term or the denominator of the second term should be equal to 0. Suppose the denominator of the first term is 0, the transient probability is calculated by assuming h cross omega ml minus h cross omega term is equal to 0. See here, if you multiply this omega ml is equal to actually omega m minus omega l, then this h cross is allowed to operate h cross omega ml minus h cross omega, that is equal to h cross omega m minus h cross omega l minus h cross omega. Just this term into this one and this term h cross into this one, not I, h cross into this term, h cross into this term. This is actually em, this is el minus h cross omega. This is the value of the first denominator. If em minus el minus h cross omega equal to 0, then em minus el is equal to h cross omega. It's a positive quantity. Then em is equal to el plus h cross omega. This provides absorption process. The perturbation describes absorption process, which means that the mth state is above the lth state. Suppose an atom is in the lth state. As a result of perturbation, the atom is transformed to the mth state by absorbing some amount of energy. So, this condition em minus el minus h cross omega equal to 0 leads to absorption process. Under this condition, the second term of equation 4 is 0. See here, this term is 0 totally, because h cross omega ml is actually em minus el. This em minus el is a positive quantity, that is h cross omega. Instead of this h cross into omega ml, we can put h cross omega. See here, h cross omega. Then h cross into omega, h cross omega. So h cross omega plus h cross omega, 2h cross omega. The denominator of the second term is changed as 2h cross omega. 2h cross omega is the larger value term, so the entire term is vanished. Minus of some fraction we can get, we can neglect that fraction. So this term is vanished. This term is removed. To calculate the transient probability, we should consider the first term in our account. So the transient probability is given by this formula. Suppose if you consider the denominator of the second term is equal to 0, actually h cross into omega ml plus h cross omega equal to 0. em minus el plus h cross omega equal to 0. em minus el is equal to minus h cross omega. This explains the emission process. See here, the lth state is above the mth state. The transition to the mth state is explained by the way of emission, which means that the atom is in the excited state, that will be coming to the ground state by the way of emission. So the perturbation induces the emission here. The transient to the mth state is explained by the way of emission. See here, if em minus el plus h cross omega equal to 0, the denominator of the second term is 0, so this term is 0, you may get Em minus El plus H cross omega equal to 0, Em minus El is equal to minus H cross omega. This describes emission process. The transition to the mth state is emission. Here the transition to the mth state is absorption. To calculate the transition probability, we have to discard the first term. First term, this term is not taken for our account. Only the second term is taken because H cross omega ml is a negative quantity. See here, H cross omega ml is Em minus El, that is equal to minus H cross omega. Here H cross into omega is minus H cross omega. So this is modified as 2 times H cross omega with a negative sign, so that this term is discarded. To calculate the transition probability, only this term is taken into our account. So this is the transition probability. In this way, the perturbation could explain both absorption and emission processes. Suppose the mth state is above the lth state, absorption is predominant. If the lth state is above the mth state, the emission is predominant. Anyway, the transition probability or transition to the mth state is possible if this condition Em minus El equal to plus or minus H cross omega is satisfied. Otherwise, transition will not be taken place. That's all about our harmonic perturbation.